So I want to go over the homework, but I also want to go over with you the perfect summary, making sure you get the three things, the three key points to a perfect summary. So here we go. So remember, the way that you know that your direction will go is based off of which item is explanatory. So in this case, since the gender is attempting to explain the type of vehicle, so then our fractions, and that's over here on the left, our fractions go left to right. The male and female are your conditional, because conditional upon you being male and female, these are the rates at which you would have those cars. And then the total on that in that direction is the marginal. Okay. Now, when you compare, you have to compare a marginal. So this is the male's SUV. And I want to see if the males have SUVs at the same rate as overall. So always compare a conditional to the overall SUV. And since those are different, then I know males are definitely not having things at the same rate. And so females also are different than that. Okay? So the gender is affecting the rate and changing it. So here are the three things I want you to include in a perfect write-up. And I don't actually have mine. So I first want you to tell me if it's independent or not independent. So in this case, were the gender and type of car independent or not independent?
Not.
Not. Okay. So in this case, it was not independent. And we're going to explain what that means. And if you need a sentence starter for that, you can do the one in the song, which says the fact that you are one thing does or does not change the rate. So let's say something about this. So independent, not independent, what does that mean?
They relate.
The gender, or the fact that you are male or female?
Does.
Okay. The fact that you are male or female affects your car type. Okay? So I want you to decide what it is. I want you to explain what that means in layman's terms, because that's part of what you are to do from this class, is learn how to communicate. And then give me a specific numerical statistical support. So let's go up there and look at it. There's lots of different ones you can do. So up here, we could say, what's one thing we could say?
That the males are more likely to have sports
Okay,
cars than
males are more likely to have sports cars than females. And I would reference 65% versus 25%.
Do we say they're 40% more likely?
You could say that. You could say 40% more likely.
I thought,
So if they're not independent, then you can just basically just compare the male and female?
Pick any comparison. You can do conditional to conditional, or you could do, like, compare conditional to the marginal. Okay? Because I just want one thing that's telling me that. So males are 40% more likely to have sports car than female. I'm still going to put the numbers because you don't know where that is. So 65% versus 25%.
So could you just say males are more likely to have sports cars than
Yep.
females? And just
And then,
put those
yep.
numbers?
You don't have to put that. This is optional, but this you need to have.
Wait, did you say there was a scenario where you have to compare it to marginal?
Yes. In order to determine independence, you have to compare conditional to marginal. To make your decision of independence, has to compare conditional to marginal. And the reason is because if you have more than two items, then two could not be, and one of them could be. Or anyway, let's go down here to this last one. What does this tell me? The fact that these items are independent, what is that telling me about all of these rates here?
It's all going to be the same.
Related.
They are the same. So this rate that for the numbers I was given, 33 out of 220 is 15%. So because they are independent, then I know females also have the same rate and the total also has the same rate. So this telling me they're independent is how I knew these rates were the same then I could just figure out what is 15% of 160, and that was 24. What is 15% of 380, and so on. Okay, questions there. There's your numbers. Okay, you get 160 by going 380 minus 220. Okay, it's okay. All right. It's okay. It's all good. Okay. Now, look here. Simpson's paradox. Let's remember what Simpson's paradox is saying. Simpson's paradox, so just a real quick review. We said that overall, player A was the best hitter, 32% versus 30%. But when we separated it into left-handed pitchers and right-handed pitchers, in both cases, player B was better. So player B was better with the separate groups, and player A was better with the overall. So do you remember the song? The conclusion you make from the separate groups is different when combined. Hey, why does it do that? They added those fractions wrong. So let me explain. So look here. They added, so here's what technically happened. They took this 28 over 81 and they added it to 5 over 22, and that is not equal to 33 over 103. If you had done the addition correctly, then if you had added correctly, then here's what you would have gotten. 30% for A and 32% for B. So which one is better overall if you had added correctly? B, which is what it shows us to be the case individually. Okay, so it is that adding those together incorrectly that messed it up. You should not have added across that variable because that variable matters to be separated. Okay, moving on to the next set of information. Okay, here you go. This one was where the employment was affecting. Okay, so here these two sections were your conditional, and then this overall was your marginal. Okay, so again, compare conditional to marginal. So this conditional owned, I compare to overall owned. All right, and that's definitely a different value. So let's do a conclusion. What's the first thing in your conclusion you need to say? Independent or not? And this was not independent. Okay, then interpret that. Okay, good. The fact that you're employed affects whether or not you own a smartphone. Perfect.
Did you say affects the rate of smartphone ownership?
Yes, absolutely. Affects the rate of smartphone ownership is perfect. Okay, and then the third thing is a specific numerical value. So tell me one specific numerical value I could say. Good, I hear it all. I hear you. If you're employed, and that's interesting that y'all all chose that one. If you're employed, you're this much more likely, or you're more likely to own a phone than overall. Or you could even say, then if you're not employed, okay? But put the numbers down. Do you see how I have numbers in my answer? Support with numerical statistical data. Okay, moving on. What was the explanatory one on this one? The class explained the survival, or survival explained which class you were on?
Class explains.
Class is explanatory, so that means that your fractions went this way. Class is, and all of these here were conditional. The class you were in, conditional upon you being in a particular class, at what rate did you survive? Okay, so that's what was happening down here in the bottom. Conditional upon you being in first class, 37.3% died and 62.7% was saved. So these were all conditional upon you being in a particular class. Thank you.
Right?
Yes, and you knew what I was trying to say, so that's pretty good. All right, and this marginal, this is overall on the whole entire ship, those that were lost and saved. And again, for independence, you compare conditional to marginal. So I'm going to compare any of these down here in the lost to the overall lost. Compare all of these conditional to the overall saved. All right. So definitely they are very different. Therefore, conclusion. First thing first, not independent. Tell me what that means in layman's terms. Perfect. The fact that you're in a particular class affects your survival. That's what I heard, and that's perfect. And then, for example, and give me one thing that is exact numerical data.
If you were in the first class, there's a higher chance of survival rate than if you were in the second class.
Okay, you compare, yep, that works.
Percents.
Okie dokie. And then 16. Okay, let's actually talk real quickly about this graphic. Lots of things wrong. It also doesn't have a key to tell you what these fruits stand for. Is the size of the fruit supposed to stand for how many fruit they are, or is one fruit supposed to stand for a certain amount of bushels or pounds or what? I don't know. And with the cherries, is that 8 cherries or 4 cherries? I don't know. So there's just tons of different things. The area principle is off. And other things. Moving down here, I think we're past it, so I'm just going to skimming over it. It was not independent. But I want to go over the one that you just did. So let's go over the warm-up that you just did here in class. Okay. This is so interesting, I think. I think this is a real-life example of a medical study. So here, if you have small kidney stones, which treatment would you prefer?
A.
I want treatment A because A is going to win. It's going to have a higher success rate. If you have large kidney stones, which treatment would you like to have? A, okay? Because they had a higher success rate. Now, overall kidney stones, which one does it show had higher? Okay. And that is called Simpson's paradox. When the conclusion you make from the separate groups is different when combined. That's Simpson's paradox. And hey, why does it do that? They added those fractions wrong. They added, look in this particular case, they added 234 over 270 plus 55 over 80, and that is not 289 over 350. We did the math in an earlier class where I had a couple of students add them correctly and get the common denominators properly, and when they added them correctly and got the common denominators properly, this bottom line ended up having 83% for treatment A and 78% success for treatment B. And in that case, which one is the winner? It is A. So if you crossed those groups correctly and you averaged those percentages, also is another way you could do it. If you added 93 and 73%, and if you averaged 87 and 69%, it gives you 78. So it would be correct that way. Yes, ma'am. You need to know hey, they added those fractions wrong. I don't think you have to show me one of those, but you could. But you do have to know that there's a discrepancy because the conclusion you make from the separate groups is different when combined. And the last one I want to go over with you because this one ends up being independent. So let's talk about this. What was affecting the other?
Yeah, how early or late your discharge affects your rehospitalization.
Okay, good. If you were discharged early or late affects if you got rehospitalized. So this means these two rows over here are your conditional, and this total row here is your marginal. So I'm going to go ahead and do all my fractions in that direction, and now let's look at this marginal. Overall, 12.6% of people have to get rehospitalized. How do I check for independence? Compare what? Conditional to marginal and conditional. So I'm going to compare this 13.5% to the marginal. And I'm going to compare this 11.9% to the marginal. If they are within 1% of that marginal, then they are good to go.
Oh.
Yep. Is 13.5% within 1% of 12.6? It is. It's 0.9. Is 11.9% within 1% of 12.6? Yes, it is. It's 0.7. Okay? Let's do the other. Is this here 86.5% within 1% of 87.4? 87.4? Yes. How about 88.1? Is that within 1% of that? Yes. So the conditionals are within 1 percentage point of the marginal. That's considered consistent and somewhat the same rate, because you can't always have exactly the same because of the way fractions are and just the number in your sample. So that is independent. Independent. The fact that you were discharged early or late does not impact the rate at which you could be hospitalized. What do I have missing here? And actual numerical data. So a way you could say that is just give one of them. You could say something like how the 86.5 and the 88.7 are within 1 percentage point of the overall rate of not going into the hospital, 87.4. So just somehow describe and put some numerical data in there to support your decision. Okay, that's it. That's all of the going over. You do not have homework tonight. That was a tough decision. It makes me a little nervous, but I think that the last thing that we have to learn is tomorrow, and that's just physically creating a box plot. And I think we can accomplish that tomorrow and finish it in class and have you even practice in class. And then you'll do the review tomorrow night, go over it Wednesday, test Thursday. All right. Yes.
If we say